How to create flexible Java code. Welcome Java Challenger. By learning the principles of this video, you will be able to create robust Java code and it will help you stand out as a Java developer. I'm Rafael Del Nero, a Java champion, and today I will show you the solid interface segregation principle. So now let's explore the fundamentals of the interface segregation principle. The first thing to keep in mind is that we need to create specific interfaces. So those interfaces, they have to be cohesive for that set of classes that will implement those interfaces. And we also need to segregate responsibilities. Why? Because if we keep lots of responsibilities in just one interface, what will happen is that several classes will implement this interface, but they won't have anything in some methods. They won't have any implementation in some methods, which is bad. Basically, we need to remember that every time we use inheritance, we need to implement all methods. Those methods have to mean something to the class that implements this interface. And we need also to create those interfaces in a client-oriented way, which means that we need to think in a way that those interfaces can be reused and passed as a parameter. And the other thing to keep in mind is that we need to avoid fat interfaces. So fat interfaces, in simple words, are basically interfaces with too many responsibilities. So it's a huge interface with many methods, and when we have those fat interfaces, it's difficult to reuse them, because then imagine we are implementing this interface in many classes. Probably many of those classes won't be able to implement all of those methods. So avoiding fat interfaces is a good idea to implement the interface segregation principle. And the other thing is that by creating specific interfaces, we're going to promote decoupling, which means that our code won't have strong dependencies. So, and by using the interface segregation principle, it's also much easier to add new features or to fix bugs, because then you have a specific interface and you don't have more points of failure in your code. The more restrictive your code and the more specific, the better to maintain. So now let's go to the fun part. Let's go to the code. Okay, let's start from the simplest example. Notice that this interface is a fat interface. Why? Because it has too many responsibilities, and I'll show why this is bad. So let's imagine we have a human worker who work and eat. So this is fine for a human worker. But then if we use a robot worker, this eat method doesn't make any sense. So in a real application, this would make this class very confusing, because then imagine if we are using this robot worker class and then we try to invoke this method and it does nothing. It's weird and it doesn't even make sense. A robot doesn't eat. So this is the problem of using a fat interface. It doesn't make much sense. And here is just the implementation, nothing special here. So the only thing is that robot would invoke the eat method and it would do nothing. Now let's see an example using the interface segregation principle. So now notice that we have one interface for each responsibility. So the workable interface has the work method, and we have the eatable interface that has only the eat method. So now we can implement those interfaces separately, and those classes will now make sense. Let's see now, firstly, human worker. So here we can implement both interfaces and we can keep both methods. So this class is perfect. And now the benefit of this class is that we can implement only workable, and we don't need to implement the eat method anymore. So now this class makes sense. So let's see the main method. Okay, so now notice that we have the main class, and On this class, we are using polymorphism. Notice here that we are declaring this variable with workable, and we are implementing this variable with human worker and robot worker. Why? Because both classes are workable. Both classes are implementing workable. And this gives us the great power of polymorphism, which means that we can make our code more flexible. So notice here that we created this work method and we are passing only the workable interface. We are not passing the implementation here. We could pass either human worker or robot worker. But then we would have to create two methods, and that doesn't help us for code maintainability. So basically then we can pass human worker here in this work method or robot worker. Therefore, we are making use of polymorphism. And now notice that only human eater can eat. A robot worker doesn't have this method anymore. And notice that we can declare this variable as eatable. Why? Because human worker is implementing eatable, so that's totally fine. That's polymorphism again. So now let's run this class to see what is the output. As you can see, we have human is working, robot is working, and human is eating. Let's see now an example closer to the real world scenario. And in this example, you see an interface user that can create content, edit content, delete content, and publish content. You see right away here that it is a fat interface, so it's doing too much here. And let's see the interfaces that implement user. So the admin user can do everything. The editor user can't. The editor can only create and edit content, and those methods won't be implemented, which is bad. And then we have the viewer user who doesn't implement any of those methods. And then in the main method, so the admin can do everything. The editor invoke those methods, but nothing happens, and the viewer can't do anything. So this is bad design. So let's see now a similar example using the ISP concept. So now notice that we have an interface for content creator, another one for the deleter, for editor and publisher. So you see that now we segregated each interface, which means that now we can implement them as necessary. So the admin user will implement all of them, and the editor user will only implement the content creator and content editor, and the viewer user won't implement any of them because the viewer can only view the content. And then we have better code here because now we don't have useless methods in the editor, for example, or we don't have the create, edit, delete content and publish content implemented in the viewer instance. So now we have more specific code that does what we are expecting. Now let's see the payment example. So as you can see here, this is also a fat interface, which means that it's an interface that has too many responsibilities. It pays, it gives a refund, it validates a card, it also processes online transactions. It does too much. When we implement payment on cash payment, we can already see that we have methods that we can't do anything. We can't validate card and we can't process online transaction. And on credit card payment, we can do everything here. It's totally fine. Then as you can see, we can invoke all the credit card methods, but then on cash, those methods don't make sense. Now let's see the example using the interface segregation principle. So let's see the interfaces first. So notice here that we have the card validatable interface, we have the online transaction processable interface, payable, and refundable. So notice that we already segregated the interface's responsibilities. And now let's see the implementation classes. So now cash payment can implement only payable and refundable because those are the only actions that this class can make. And we also have the credit card payment which implements all of those interfaces because it does all of those actions. And then here we instantiate credit card payment, and we can do all of those actions. And we invoke only the pay and the refund method for cash payment. The most important principle to remember from interface segregation is that we can't implement an interface and do nothing in a method. And this is the same for inheritance. If we are inheriting a class, we must use all of those methods, all of the methods from the superclass. So keep that in mind. And if you see that there's nothing you can do, you can't implement that method, or you would throw an exception, then it's better to segregate. Then you break down interfaces, and you do what we did here. Okay, so just to recap, avoid using fat interfaces, which means interfaces that have too many responsibilities, because as you could see, if we implement those fat interfaces, it's very likely that in one class or in the other class, we won't be able to implement all of the methods, and that will make our code more difficult to maintain because methods that do nothing, they are confusing. And please remember to implement this principle whenever possible in your application, otherwise the knowledge is useless. And I also would like to invite you to my live webinar on the 27th of June. I'm gonna leave the link here below, so you just need to click on it so you can get subscribed for free. And in this webinar, I'll help you to stand out as a Java developer and to become a highly paid Java developer. And that's pretty much it. I hope to see you there, and take care.